I will preface this solution to this week's Alteryx Weekly Challenge by saying that this brute force method isn't something I'm particularly proud of, but hey, it works, right? So we look at our initial input that we get given, this little equation, and think, okay, what we're probably going to want to do is split this out into individual letters. So we use text columns to split to rows on spaces initially. Then we kind of get rid of the plus and the equals sign for now because we don't really need them. Split out our letters using a tokenize in the regex tool, and then we kind of need to assign the coefficients to these letters. So what do I mean by that? So for example, if a letter is in the units column, then it needs to be multiplied by 1. If it's in the tens column, it needs to be multiplied by 10, etc., and so forth. The issue kind of comes with the fact that money has 5 columns, whereas obviously send and more only have 4. So we need to just number them, sort them in a descending order, and then use a bit of logic where we're saying, okay, the first row we multiply by 1, otherwise multiply the row above by 10 to give us those multipliers. Now we're doing a little bit of logic here where we want everything to be brought over to the left-hand side of the equation so that we can basically do some grouping and summing so that we have the right coefficients. So for example, where we have the e's, these two e's are on the left-hand side, so we'll sum them together to make them 101, because that's kind of the coefficient that would work there. So we do that, so we break them off into the left-hand side and the right-hand side, do some summing, bring them back together, stick them all together, and this is what we end up with basically by doing that summing. So we get to this stage and we think, okay, now we need to start working out, doing our testing with different values for our letters. And this is where this gross stuff comes in at the bottom. I just have the numbers 0 to 9, and I am going to just append that to itself and filter out the rows where I don't want the rows where they're duplicate values. So I wouldn't want there to be 0 in both these rows, in both these columns, sorry, in this row. So that's kind of the logic behind what I'm doing in this horrible section here. Obviously, you need to remember in like each filter tool to add on different conditions, because obviously more rows are coming through. You need to check for all of it against all of the existing rows, basically. So that's, yeah, that's the shameful thing that I did there. And then we just need to number each of these and transpose them so that our first record that was before our transpose is just the numbers 0 to 8, etc., and so forth. So we do that, and then we just number these from 1 to 9 as well, so that we can join them up to this record ID up here, all the different possible solutions that it could be. Again, horrible brute force, and we get back, 29 million rows. That doesn't seem right to me, but it works in the end, so we're just going with it. So from there, we multiply our value that we have by the multiplier. That was the coefficients that we calculated before in this section over here. We group them by the record ID that we added to it here and sum them. We're looking for it to equal 0, basically. So filter all of those where it equals 0. There are apparently 50 records where that's true, which is great. So we join those back together, and now we need to do some checking if either M or S is 0, because we can't have that, because the numbers can't start with a 0 by the definition of the problem. So we set up a flag to say, hey, if the M or the S is 0, then give it a flag of 1. And we take the maximum for each record ID so that those values will show up as a flag, and we filter it to just have those where it's not been flagged, and we join that back on so that we now have these two options where it gives us the right values. These are actually replicated, so I'm not sure what I did wrong here, but we have basically, if we group them just by the problem and the value, then we get our solution, which is great. So the only thing left to do is to join it back to all the way over here, sort of back when we had assigned the order to it, and then union in those plus an equals sign, and do some sorting so it's all in the right order. And finally, we just make sure that we add a space between either side of the plus and the equals sign. Operators, I think that's the word I'm looking for there. And then we concatenate all that together to give our solution, which matches the desired output. So I don't think this is my proudest work, but I am looking forward to seeing how others did it. So far, I think on the community, I've just seen brute force solutions. So I'm looking forward to seeing some that aren't brute force, that possibly use binary logic in some way. So let me know if you have any ideas of how to not brute force it. I'd be really interested. So thanks for watching my terrible brute force solution, but thanks anyway.